Alright, welcome to this next exclusive video on the quotient, the logarithmic quotient property, which is log base b of a minus, instead of a plus sign, log base b of c. Okay, in the previous videos, when it was a plus sign, what do we do to the inputs? We multiply. So naturally, you might think, if you're subtracting, what do? Well, you're gonna get log base b, and naturally you would think they would divide, and in truth that is the case. This is our formula for the quotient property. All right, well, let me just show you an example of why this property works the way it does. Let's write log base, I like working with 2. Let's say 16 minus log base 2 of and let's say 8. All right, well, according to our equation, we take the a, right, divided by the c, since it's a minus sign. So it's 16. It's going to be the a, which was this 16, divided by the 8, which goes here. So we're going to get log base 2 of 16, oops, I almost put a plus sign, minus log base 2 of 8 is equal to log base 2 of 16 divided by 8 is 2. Okay, well, let's think this through real quick, just so we know. What does this logarithm tell us? Since we're just dealing with actual numbers and not letters, this is actually telling us 2 raised to what power is 16. And if you do this on your calculator, you'll find that this is 4. So, all right, so we're going to get 4 minus, because again, this whole thing, it says 2 raised to what power 16. That's 4. Okay, this is saying 2 raised to what power is 8. Again, because 2 is the base, 8 is the input, which now becomes the output. Just applying the inverse, the definition of a logarithm. Well, that's 3. Well, what's 4 minus 3? Well, 4 minus 3 is 1. So this better be 1. Well, what's 2 raised to what power equals 2? Well, that's 1. That's just 1. So that makes sense. So if we were to actually compute these, we get 4 minus 3, which I wrote here, and it better equal 1, which it does. So that's kind of another way to show you why this property works the way it does. All right. But more importantly, we just want to be able to apply the property. So let's check it out. Let's say we have log of 2. Let's write xy minus log of 2 of just y. Well, this is going to become log base 2, and we're going to get xy. Since it's a minus, it means divide, right? So you take the first input, so I'll write xy divided by the second input, which is y. Well, since we're dividing, what's going to happen to these y's? Well, they're going to cancel out, and so we're just left with log base 2 of x. All right, pretty cool. Let's try maybe another example problem. What color would you like? Okay, I think I read your mind. You wanted some pink. So let's go ahead and do that. Log base of 22. All right. And let's say 14x squared times y to the 8 minus log base 22. And let's say 2x times y to the 3. Well, this is going to equal log base of 22. We're going to get the first expression, which is 14x squared times y to the 8th, all divided by the second expression, all right, which is going to be 2xy to the 3. Okay, and now we need to simplify this. So we're going to get log base 22. Okay, well, 14 divided by 2 is 7. So this is going to give me 7. I have x squared and I have 1x on the bottom. That's the same thing as x times x divided by x, right? There's 2 x's being multiplied on top, 1 on bottom, 1 cancel. I'm left with an x on the top. Over here, I have y to the 8 divided by y to the 3rd. So I have 1, 2, 3, 4, 5, 6, 7, 8, all divided by 3 y's. Well, these 3 cancels here, and I'm left with 1, 2, 3, 4, 5. So I get y to the 5th. All right, cool. And again, one little trick, if you remember, when you're dividing with exponent property, subtract. 8 minus 3 gives me the 5 here. Okay. All right, well, let's go ahead, maybe try one more of a challenge problem. Let's say log base 33. I don't know, I'm just choosing random bases. Let's say x to the negative 2 plus, let's say minus log base 33 of x to the 4th. Okay, well, this is going to be log base 33, the top x to the negative 2 divided by the second input x to the 4th. Well, what do we do with negative exponents? Well, with negative exponents, you just flip it. A term is positive, you flip it, and that's just going to go right down on the bottom. Well, how many total x's do you have on the bottom? It's a 6. So 1 over x to the 6. And that would be my expression there. Cool. All right. Just why not? What the heck? Let's just do one more. Let's try log of 4. Let's do 20x squared minus log of 4 of x squared minus log of 4 of 10. So we have 3 logarithms. So all right, first things first is let's just focus in on these two here, right? So these two are going to equal log base 4. Well, the first input, so 20x squared, all divided by the second input, which is x squared. And we still have this minus log base 4 of 10 on the outside that we're going to address in a moment here. Cool. All right, so what's going to happen is the x squareds are going to cancel out. So I'm going to get log base 4 of 20. Whenever anything cancels, just 1. So 20 times 1, that's just 20. That's why you don't have to write anything, right? Don't confuse this to be 0. It's 1 minus log base 4 of 10. Now we can do this whole process again, and we'll get log base 4, 20 divided by 10. And because it's a minus sign, you divide, and you're just going to get 2. And you can actually even solve this problem here, because this is now going to be 4 raised to what power is equal to 2? Well, that's 4 raised to the 1/2, which is equal to 2. So this whole thing right here is actually equal to 1/2. Remember, the 1/2 is the same thing as the square root of 4. It's like an invisible 2 here. So square root of 4 is 2. That's why it's 1/2. All right. That's all I had for today. Hopefully this made sense on an introduction to the quotient property.